Push it out like butter. I can't push on this crazy hard because I'm supporting it out here, not here. There it is, we just touched off. Oh, bearing moving easily. Look at that. Look at that. You start chopping for a lathe yet? I think I just touched the other bearing. Felt the pressure increase a little bit. Yeah. You'd have to go to a machine shop to have this done. And it's easy. Ooh. Maybe now I'm hitting the other bearing. I might get the whole gear out. It's an increase in pressure. That probably was when I hit the bearing there. Feel one drop into my hand at any moment. Guess I could have turned this over and pushed it through the other way. Whoops. Looky there. Look at that. Might run out of stroke. Should get the tool. Oh, there we go. I didn't drop my bearing though. There's my tool. That's the star of the show right there, baby. Star of the show. So now I got to figure out how to get that gear out of there. So here's the scenario. We got to push out this gear. Remember we took the bearings out last. And it's got a stem that goes into about right here. So here's what a replacement gear looks like with a stem, and that's up inside of the cone pulley. And then that stem is about 90 or 100 thousandths short of another step in here, so there's a gap in there. I thought about getting a snap ring to put in the gap, which would be kind of hard to center up, and then I could use my tool to push against the snap ring, but I don't have a snap ring that size, and I'd have to wait a couple days for it to come in the mail. With shipping, it'd be $8 or $10. So I found these really thick washers that actually are pretty tight in the gap. And the gap where I've got the washers is resting against this edge. I actually put a screwdriver in here and drove on the screwdriver to tighten all those up. So they're not coming out. And my gamble here is that my close-fitting pushing tool that I made, I should be able to push against those washers and drive the gear out of this cast pulley. And I'm going to support this gear really close to the edge here. I don't want to break these flanges off. If it gets a little dicey, I don't know, I may make something that supports this better if it takes very much pressure, because I don't want to break this cone pulley. They're expensive. But that's my plan of attack. So let's see if we can push it off of there. I'm going to move this hammer because it'll fall for sure. Well, this doesn't want to go in this end of the tool. Let me clean it up. 3/4 inch drill bit. Slips easily into this side, but not out the other side. So we'll, must be some taper in that hole or something. We'll clean that up. Let's take a kiss out. There it is. 3/4 inch is pretty close to the bore of my spindle, so I don't want to touch that in there, although there's a taper there. Oops. There's a taper there, so probably couldn't touch anything, just to be careful. Now my mandrel should go right in. Just barely cut anything in there. It's just like OJ's glove. I don't want to take that up any more than I have to. There we go. Scoot the plates in. Let's see if we can eject that old bad gear out of there. Ooh, we're getting tight. I think it's moving, it's moving. I love my Harbor Freight 20-ton hydraulic press. washed it out like butter. I wasn't prepared for all that weight, but I did catch my gear. And 2 of my 3 washers. Nope. Still one missing. Wow, so there's that gear. And there's that bad tooth. Bad tooth! There's the other washer. Now I'm going to go put all my pieces away. Look at all those chips. Ugly gear. So let's compare these 2 gears. They look the same. Oh, uh-oh. My replacement gear has too small of an OD. Damn. So I really don't have the right part for this. It's the right gear on the outside. I may have to make up a collar to press over this. I wonder, this is a 10-inch lathe and I've always thought it was a 9, so I was asking for parts for a 9. I bet you this is for a 9. Dang. Oh well, we can solve this problem too. I need to change this chuck to a 4-jaw chuck. I'm going to center this gear up and take this bad gear and take a sleeve off of here to repair or to size up the stem of my gear that's too small. And a lot of people will get their chucks off of the thread like this. Bad mistake. It's hard on everything and the shock can break these Zamac gears. So I use a piece of hex stock, and I order hex stock occasionally. When I order hardware from McMaster Car, it's no big deal to get a piece of hex stock. It's a little bit at a time, doesn't even seem like you're spending money. And I've used this hex stock for several projects. But here's what else you can use it for. You can chuck it up in your lathe and use it as a way to get a hold of your chuck. And turn it off. Wow, that was really tight. Look how easy that was. And you can also use a piece of stock like this as a handle to hang on to the chuck. I'm going to put my hand under here. A block of wood's good too. My tailstock's in the way. There we go. So there's a very good way to remove a chuck from an older lathe with a thread-on chuck. An Atlas, Craftsman, a South Bend, a Logan. A lot of these home workshop lathes use this method to hold the chuck on. And spinning on the new one. The 4-jaw. There we go. Now we can get this gear mounted and dialed in. First thing I got to do is dial in the face and get this correct. That's hard on the needle. That's soft. This is just where I started, so I got pretty close. So there's the hard spot. I'm going to raise that to the top. Already got it within 2 thou. There's the hard spot, right where that speck is. Might have went too far. Nope. There's the hard spot. There's the hard spot. I'm going to come back and look at this. I'm within 4 or 5/10 of a thou right now. I'm going to work on the OD, and then I'll come back and look at this. So we're off by about 20 thou. And that's hard, so we've got to move both of these jaws in. I'm going to loosen these others slightly. And now I'm just going to work between this jaw and the other jaw. This is hard. Purple's hard. Okay, so that's hard. Okay. Okay, so we're hard about 2 thou here. I'm going to lighten up that slightly. Not sure what I did there. Did I lose what? I think I lost track of what jaw I was on. We definitely need to tighten this one up. Loosen this one. I need to number these. Opposite jaw. A little bit hard. Move the part away. Ooh, bet you I'm about perfect. Look at that. Okay, so now let's work on these 2 jaws. Zero. 0. Hard by 2. Hard by 1. Hard by 1. Hard by about 8/10. Hard by about 1 1/10. Look at that. Those 2 sides are within 1 or 2/10 of each other. This jaw and this jaw. This jaw's a little soft. Oh, wait a minute, going the wrong way. This needs to be a little tighter. Seems to go the other way. There we go, there we go. Zero, 0, 0. And this one's hard. It might be, with the chuck, distorting the shape of the part slightly. Zero. About 3 or 4/10. 0. About 3/10. Okay, so we're a little bigger this way than this way. Slight bit of ovality. Now the reason I have some teeth hanging out here is I have to, after I machine this bore, I have to cut the teeth off in order to make room for the cutoff. And I don't want to get into these pins of these this repaired tooth here, because that could be music wire or something really hard that I might not be able to touch. Now let's come back on the face here and see if I've got the face straight or not. So we're a little bit hard. Wow. That's a little bit hard right there. Yeah, we got the needles floating. Look how close that is, guys. Look how close that is. Do you have a dial indicator? I'm gonna check my. Check this and make sure I haven't fouled it up. Whoa. Yep, it's moved. I think we're within just a few tenths of a thou. There it is, boys and girls. Let me shade that so you can see it. That's 0, 0. 2 tenths. Minus a tenth. 3 tenths. 0. There's the biggest offender, about 4 tenths. Let's move this one. We're going to slide a bit of out around this here, but we're within 2 or 3 tenths of a thou. That's good enough. That's how you dial something in. Now we can machine this bore. We're going to machine this bore out so it's a light press fit, about half a thou, onto the other gear. And if it comes out a little bit big, we can use sleeve compound to glue it on. And then we won't touch this bore. We'll use the ring off of here to press our other gear into the cone pulley to size it up. And in this way, we'll take this piece of junk and make something out of it, and I won't have to wait on a part. This will be our first serious boring operation. So we're going to take that out until this will press in. Then we'll press it on, line up these 2 holes, and then we'll be able to install this gear on the Logan lathe. I can use the largest boring bar I have. Shorten the boring bar just to make my whole tool assembly stiffer. I'll hit this with a plastic hammer so I don't, so just in case I miss and hit my tool, won't chip it. There we go. That should be hanging out plenty.